Hello students, welcome back to this session. In today's session, we will be seeing relations and function theory, and in today's session, we will be mainly covering the section 2.4. Okay, so before going in the lecture, there is a small disclaimer. The images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Thank you. In today's session, mainly focusing on functions, the definition, some related example, the terminologies. Clear? And then we will be doing some related examples, NCERT examples 7, 8, 9, 10, 11. Okay. If time permits, we will be doing some DPP questions as well. So, the definition, what is function? A relation F from a set A to set B is simply said to be a function if every element of set A has one and only one image in set B. Clear? So, this function F is nothing but your relation, first of all. First thing first, this is your F. Now, if you recall the relation, what is your relation? Anybody memorize the relation definition? So, now here, in another words, function is your relation from a non-empty set A to a non-empty set B such that the domain of your relation F, the domain of your relation F is complete set A, and no two distinct ordered pairs in F have the same first elements. Clear? So this is your function definition in words. So some related terms. Preimage. What do we mean by preimage? If F is a function from A to B, so this pair F function, meaning this is your relation, this is your set which is a subset of A cross B. So elements of this relation F of the form ordered pair A comma B, where A belongs to set A, B belongs to set B. Clear? Now, then this preimage term means that F of A is equals to B, meaning B is your what? B is called the image of A under F, and A is the preimage of B under F. Simple. What we are saying is simply B is your image of what element? A, and A is your preimage of what element? B. Clear? So if you try to see in this order pair, A is your preimage, and B is your image. Simple. B is your image of A, and A is your preimage of B. Okay? So you must know about these two terms, preimage and image. What do we mean by preimage? What do we mean by image? That's it. Now, some related example. All will be clear here that what do we actually mean by function. what is the main difference between any relation and a function. So suppose you are having your set A with 6 element 1 2 3 4 5 6. Define your relation R from A to A itself by collect all your pairs, ordered pairs x comma y. I hope that you all remember what do we mean by ordered pair. Ordered pair meaning any pair in which uh, order has relevance. Yes. So in this case, collection of all ordered pairs x comma y such that x and y are related in this manner, that y is equals to x plus 1. Clear? Now first depict this above diagram, or sorry, the above relation using an arrow diagram. Second, find out its domain, codomain and range. So solution. So by the definition, first of all, write your relation in roster form. So just place 1 in place of x, you will get y as 2. So 1 is related to 2, 2 will be related to 3, 3 with 4, 4 with 5, 5 with 6. Clear? Now, in order to, so first of all, this arrow diagram, how my arrow diagram will look like? Quite simple. What you have to do is simply just make a oval shape. Clear? And inside it just write all the elements of set A, and at the left hand side make the oval shape and write inside the elements of set A, because we are going from A to A itself. Now 1 is related to what element? 2. So we are going to draw a line, so originating from 1 and terminating at simply 2. So this is our line segment which shows that 1 is related to 2, and this arrow shows that we are going from this set to the set at the right hand side. Clear? Now 2 associated with 3, meaning 2 related with 3. So a small line segment originating from 2 terminating at 3. Now 3 with 4, 4 with 5, 5 with 6. Clear? So why 6 not associated to any element? Why? Quite simple, that 6, if you substitute 6 here, what will be your y? Y will be 7. But 6 comma 7, this ordered pair not going to be in this relation R. Why? Because in order to get any ordered pair in this relation R, both elements of your first and second position of the ordered pair must be from where? From set A. Clear? But 7 doesn't belongs to set A. So we are having 6 is not associated or related to any element. Clear? So this will be our arrow diagram. Now for domain, so what you have to do is quite simple, that collect all the first elements from the ordered pair which are in the relation R. So 1 2 3 4 5. So domain set will be not my A set, not A. This is not equals to set A. So domain is simply this set with 5 elements 1 2 3 4 5. Clear? That how we are getting our domain. Now range set. Range set simply collect all the second elements. So 2 3 4 5 6. 2 3 4 5 6. So this will be your range set. Now what about the codomain? Codomain is your complete set which is at which is here, the right hand side. Clear? So with 6 element 1 2 3 4 5 6. Now the element 6 has no image. As we just saw, what do we mean by image? What do we mean by pre-image? In this context, if you see, say 2. 2 is your image of what element? 1. Yes? Or you can say, are we having any image of 6? Are we having? No. There is no image for element 6. Clear? So no image for this element 6. Is it clear? Therefore, what we can say is that this given relation is not a function. If you recall what we have just seen in the previous slides, that function meaning, so in order to be a function, a relation must satisfy some points. What points? First of all, my domain set must be the complete set A. In this case, domain set is this, and this set A, this set, the whatever set present over here is not equals to the domain set. So, not a function. Clear? I hope that why this relation is not a function is clear to all. Quite simple. In definition, just see the definition. What we want is, if any relation is a function, then every element from the set A, if your f is A to B, if your relation is A to B, if your relation is A to B, then for every element in this set, there exists some element which is associated to it of B. Clear? But we can easily see that we do not have any element which is associated to this element 6. So, not a function, not satisfying the definition. Now, another example. You are having an arrow diagram simply from P set to Q set, which exhibits what? A relationship between P set to Q set. From P to Q. We are going from where to where? From P to Q. Simple. What you have to answer is simply, first of all, write its set builder form, then write its roster form, then also give me its domain and a range set. Simple question. Solution. It is obvious that R, so for this, that how we are going to describe in set builder form, quite simple, that R, simply how elements are related, simple, that X is your square of Y. So in set builder form, R, collection of all ordered pairs X comma Y such that X is a square of Y, where X belongs to set P, Y belongs to set Q. So in roster form, you will write 9 associated with 3, 9 associated with -3, as you can all see, 4 associated with 2, 4 associated with -2, 25 associated with 5, and 25 also associated with -5. Clear? So this is my set builder form and this is my roster form. Now for domain, quite simple. So just collect all the elements which are associated here. So as you can see, 9 is associated with some element, 4 is associated some element, also that this element 25 is also associated with some element. So 4, 9, 25. The collection of all these 3 elements will be your domain set. So note that simply 1 is not related to any element in the set P. The set Q is the codomain of the relation. Simple. So not a function, because what is happening here, simply domain. So domain elements some of the domain elements are connected to more than one image, as I have said. Is it clear? Another example. So relation is given to you that collection of all ordered pairs x comma y such that x square plus y square must be 4. Is this given relation R a function or not? Simple question. So solution. If x is equals to 1, then what you are getting is simply y as root 3 and y as minus root 3. Yes, if you substitute x1 here, what you will get is y square is equals to 3. So can you have the solution for y square is equals to 3? Yes, we are getting two solutions. One is plus root 3, another one is minus root 3. So for a given x, there are two different values of y. So R is not a function. Clear? Say example. So we are having a set A with two elements 1, 2, another set B with two elements 3, 4. And what we have to do is simply find out the number of relations from A to B. Just simply find out relation from A to B. Quite simple question. So solution. So in order to get the relation from A to B, what we want first? We want the Cartesian product in between A and B. So in between A and B, the Cartesian product will be your set of ordered pairs in which the first element of your ordered pair must belongs to set A and the second element of your ordered pair must belongs to set B. So we are having in total 4 such ordered pairs: 1 3, 1 4, 2 3, 2 4. Clear? Now, so in this, what we are having is simply just try to observe that in A cross B, how many elements we are having? 4. And the total number of relations will be 2 raised by 4, meaning 16. And if someone asks that is this, say, is this relation defined here A cross B, the complete set A cross B, and if someone says is this relation a function, so what will be your answer? No, not a function. Why? Because this element 1 is associated to more than one image, simply not having exactly one image. So this element 1 having more than one images, simple. So not satisfying the function definition. Clear? Is it clear? Okay. So moving to next. Now this question. So relation R defined as collection of all x comma y such that y is equals to plus minus root 4 minus x square. Is this relation a function or not? So solution. So if you observe that for x0, y will be plus minus 2. Meaning for x value, there are two values for y that satisfy the equation. So R is not a function because you will have an element from the domain set which is associated to more than one element. So not a function. Clear? Now this example. Let n be the set of natural numbers and the relation R be defined on natural numbers such that R is defined as collection of all ordered pair x comma y such that y is equals to 2x, where both x and y belongs to set of naturals. Then, so first find out its domain, its codomain, its range, and then answer, is the given relation a function? And justify your answer. Solution. The domain of the relation R is the set of natural numbers, meaning complete set n. The codomain is also the complete set of n. Why? Because your relation is from where to where, n to n. Yes, and the second set by definition is your codomain set. Now for range, quite simple, that range is your what? The collection of all y's. Yes, collection of all elements which appears in the second position of your ordered pair. So y, collection of all your y's. And you know that y is of the form what? 2 times some natural numbers, meaning multiple of 2, meaning even natural numbers. Yes. So range set will be your set of even natural numbers. Clear? Now, since every number n has one and only one image, so this given relation is a function. Yes, satisfying both the things. First one, that domain set is the complete set of naturals. Yes, so first point is satisfied. Now for second, that what we want is that every element of this domain must be associated to exactly one element from the codomain set, or n from the domain has one and only one image. Clear? So satisfying both the points, meaning the above defined relation is a function. Now this example. So what you have to do is simply examine each of the following relation given below and state in each case giving reasons whether it is a function or not. So simply 3 relations are given to us in roster form. So first one is having 3 ordered pairs 2 1 3 1 4 1. Clear? Second one is having 4 ordered pairs 2 2 2 4 3 3 4 4. And third one is having 6 ordered pairs 1 2 2 3 3 4 4 5 5 6 6 7. Clear? Now, so solution. So for first, since 2 3 4 are the elements of domain, yes, of the relation R having their unique images, so this relation is a function. Clear? Now second not a function. Why? Because the element 2, this element 2 corresponds to 2 different images 2 and 4, meaning this element from the domain set associated to more than one image, so not a function. Now third is a function. Why? Because it is satisfying the definition. So every element has one and only one image, so a function. Clear? So thank you.